Morning, everyone. Let me know if you're able to hear me and see me now. We'll usually start sharp at 11, so let's stick to the same thing. Um, we would kind of like be waiting for the others to join in for the next couple of minutes, but what we could do is until then I could just try to start engaging with you and a couple of things what we usually do. So since I would be not focusing on the chat box usually once I start off with things, I kindly request you, if you have any questions, I would kindly request you to post the questions in the questions tab. um, that becomes easy for us to answer those questions for you. We don't miss it out. Whereas if it goes in the chat box, then usually it becomes a little difficult to track it, right? um, Great. Questions tab, that's the first one. And before we start off, I would probably like just post a poll here, right? Just to understand why exactly you're here for this webinar. Of course, it's like you need to understand the way to learn tuning. That's point number two and point number three. Or are you expecting to completely learn how to tune an ECU, right? Um, if you are thinking of completely learning how to tune an ECU, we might not be able to provide the complete information, but I can point you in the right way about how to learn to do that, right? So if you guys could just quickly go, and if you could just make your vote on the poll, would be easy for us to understand your requirements, and maybe um, just change things as we talk to cater to your requirements, right? So just go ahead and post it out there. So even if you're looking at starting a business, then I think this would be a right time to do that as well. Quite a lot of people opening up their tuning business. The market is opening up as well. So we basically cater to all of the three segments what you see here. So go ahead and make your vote over there, so we understand what is it that you're here for. Great. So I think five of you have answered it. Super. So let's just wait for a couple of more minutes. I'll just have my AV switched off, and we'll start off sharp at 11 o'clock. So I think we're good to start off. Those of you who've joined in new, if you guys could just go answer the poll which has been put out there, for us to understand why you're here and how we could help you in a better way with these things, right? Please do go and drop your answers in the poll. That's primarily to help us with things. And let's move on. Hope you're able to see my presentation as well. This is about ECU tuning and remaps. And we are primarily going to be talking about how do you pick up skills in ECU tuning and remaps? What are the career options available? And finally, how is it that Rain Lab can help you, right? So about myself, I'm Sajid. Slide is not loaded up, I guess. Just give it a second. I think we have some internet issues. Raj, are you able to see the second slide? Speed seems to be okay. Raj, are you able to see the second slide? You can see it? Okay, great. Um, Unfortunately, I'm not able to. So just give me a second. Let me just try to refresh my screen, see like if that's helping out. Okay, great. I think now it's come up. Can't see slide numbers. Okay. Some little problem with it. Okay, hope you're able to see it now. The second slide out of the 23 slides that we have. So this is about me, what I've been doing, and why is it that I'm here to talk to you about ECU tuning and remaps. So maybe you've not seen me on the motorsports arena. You've not heard of me, but what makes me the expert, or what makes me eligible to come here and teach you ECU tuning and remaps. So I've started my career with motorsports. I was the founder and CEO of Sirius Motorsports, and I'll show you what we were doing at Sirius Motorsports. And then subsequently, I started working with OEMs. So we started working with UCAL Fuel Systems. UCAL Fuel Systems being the sole provider supplier for fuel injection systems to the bike. So they have around 90% market share or something. So we were working there. I was in charge of a project where we were converting carburetors to fuel injection. So which meant I was working with pretty much the entire spectrum of ECUs. So right from deciding what ECU goes in, what injector, what wiring harness, where the wiring harness goes, where the ECU is mounted, pretty much not just the tuning calibration part, but pretty much the entire thing. And then I started working with Bits Pilani as an adjunct faculty in the automotive engineering division. So my job there was to teach automotive engineering and automotive electronic students on quite a lot of different subjects, right? So I was handling IC engines, I was handling electric vehicles, mechatronics, ADAS, control systems, among some of the things. So that's my background. That's where I kind of learned whatever I've learned. And now for the last 5 years, 6 years, we've been teaching ECU tuning, and we've just figured out that there is a much more easier way for us to teach this to students. So now a lot of you might be still thinking, why should I learn ECU tuning? Is it just to tune my own cars? I mean, of course, that is the easiest way to relate to ECU tuning. But as we go inside, I'll explain how ECU tuning is much more than just motorsports or things like that, right? So that's what we're going to be talking about today, the agenda. And this is what we've been doing. So I've been working with OEMs, motorsport teams, and back in 2000, I think. Sometime in 2016, 2015, I keep forgetting the dates, we started working with the rally cars, and one of the first mainstream rally car. I mean, we had worked with Esteems and Honda Cities, but that was more like I mean, it was pretty easy for us to do. There was no much work to be done with it. But this particular car that you see, that was the first year that the Volkswagen Polo 1.6 was getting into rallying. That was when Volkswagen was exploring getting into rallying, and they were unfortunately not able to run a standalone ECU on these engines. Volkswagen was not supporting from the tuning part of it, so it was aftermarket tuners, and none of them could ever make it work, properly. So we started working with this team called AR Racing, and we were taking care of the calibration side, the tuning part of things. And that year, this car, it won the class, as in like 1600 cc class. Though we started two races into it and we had issues, he still managed to win the class. And the next year, by then we had quite a lot of working time with the client and things like that. The next year, this 1.6 Polo was consistently faster than the 2000 cc CDS. And in fact, if you do follow the rally scene, the car which was dominating, it is still dominating all these years, was the Mahindra XUV 500. And this car used to separate the top runner and the second runner. I mean, the XUV 500s. So Gaurav Gill used to be first, and then Arjun Rao in the 1.6 Polo. I mean, imagine front wheel drive 1.6 NA petrol, just following the four wheel drive turbocharged diesel. So that's kind of how this car was. That's when the development really took off, and then Volkswagen decided to take all the teams under their fold, and they started supporting the teams themselves. So no point supporting a factory supported team. So then we moved on, and that's when we got into OEMs and things like that. So though you might not have heard of us mainstream in any of the social media or anything with respect to motorsports, we've been always there behind the scenes. We worked with road racing, we worked with rally championships, bikes, drags, you name it, we've done it. And interestingly enough, this didn't start sometime yesterday or today. This started almost 12 years back, right? So 12 years back is when we started first working on our esteems, the G13BB. We started turbocharging it. Incidentally, we didn't kind of do a half-hearted approach. We turbocharged it. And you'll have to understand, this is a point of time when we didn't even have broadband internet, we didn't have 3G, right? So it was at that point of a time. So we did quite a lot of work, we learned, and that expertise is what I'm here to share with you guys, right? And the coursework, what I've been talking about, we've been doing it for the last 5 years, and this is what we've been able to achieve. So we've managed to place students at OEMs. We've managed to kind of get them to move forward and start working with their own companies. They've set up their own tuning shops. They've kind of moved on, and quite a lot of things they've been able to do. And me personally, I've been able to teach the same course at Aptiv. Aptiv is the former Continental ECUs, is now called as Aptiv. They are headquartered in Bangalore right now. So I've taught students from there about what ECUs are, how calibration works. Trust me, not everyone in a ECU manufacturing company knows about that. I've done the same for Robert Bosch as well. I've done it in Tata Motors, the Engineering Research Division, ERD. These are the people who develop calibration for their cars. So I was working with them when they were building the Tata Harrier. I worked with Cummins. Cummins, it's especially very a humbling experience for me, because they have such a huge operation. They are so technologically advanced, and it was an honor to go be at the Cummins office and work with us and work with them and kind of learn things from them as well. So that's about what I've been able to do, and that's also something which should give you an idea about what makes me competent enough to come sit in front of you and talk about ECU tuning, right? So now let's get on with the crux of the subject. What exactly is ECU tuning and remaps? So more often than not, what happens is people they kind of have this wrong impression that ECU tuning is just about taking a computer, connecting it to the ECU, you change some numbers and things start working, your car makes more power. Of course, from a layman's standpoint of view, that's what they see, that's what they think that we do. But there's a whole lot of thought process which goes into changing the numbers on the ECU, right? So as a ECU tuner, you'll have to understand about control systems. You'll have to understand how to calibrate something, why you should calibrate, when you should calibrate. More importantly, what you should not be doing. What does the driver require? How does the engine behave? There's it's pretty complex if you kind of go in depth into it and look at it. There is so much of things which you need to understand before you can start tuning ECUs, which is why you go onto YouTube and you search for tuning fails, right? You have a huge compilation of videos which comes where people have blown up engines, right? So this is not something which is exactly very simple, but just because I've been doing it for quite a long time, almost like a donkey's years now, we've kind of figured out an easy way of doing things, right? So though it seems to be very difficult for you to learn, Trust me, it is not exactly difficult. You can still learn it. It is not something which is like, I would say, rocket science, right? So now, before we move on, just a small question for you guys here. How many of you here still think that you need to have an engineering degree to start tuning? Right, quite a lot of people, they have this idea. Let me even go out on a limb and say, like, it's a misconception, right? So people have this misconception that you need to have an engineering degree to start tuning. So I would say, that's not exactly true. You don't need to have an engineering degree to start tuning. But if you are building something more advanced, like if you remember the first poll I posted, there was an option where you could go and build a career for yourself in OEMs. So if you're looking at building a career in OEMs, then yes, you need an engineering degree. And that degree can be in mechanical sciences, mechanical automotive production, or it can be in electronics, triple E, ECE, even CSIT, right? But you just need a programming degree. I mean, a programming knowledge, some kind of a engineering background is what is needed if you want to get into OEMs, right? Now, if you're not worried about OEMs, if you're just looking at it as a standalone career opportunity, you want to set up your business, you want to improve your existing business and things, then you don't need an engineering degree. So now I'm going to take a couple of cases. So we say ECU tuning and remaps. So I'm just going to explain what these things are, right? So the first one is ECU tuning. So when I say ECU tuning, what I mean is using a standalone ECU like what you see on the screen, and tuning primarily petrol engines with it, right? So I say primarily because 99.99% you'll only tune petrol engines with a standalone ECU. Though you have standalone ECUs for diesel engines, it is pretty expensive and not many people actually take it up, right? So the reason for not taking it up is also because it's pretty difficult to tune a diesel engine from scratch. It's a lot more complex, so they kind of leave it out. And diesels, usually they do a remap, and for usually for NA and turbocharged petrols, you would go with a standalone ECU. But standalone ECU, at present, it is not all that successful to work with the direct injection petrol also. So it's mostly MPFI petrols, NA or turbo, that you go with it. So it is very easy to tune a standalone ECU. Once you have the wiring all done, you just plug your computer directly into it. You get access to the ECU. You start tuning, right? How you tune, let's get to it in a later point. But it is actually easier. So if someone says, "Okay, I have a standalone ECU in my car. Can you tune it?" You can just plug your ECU. It'll start. I mean, plug your computer. It'll start working. Someone asks you, can you wire the ECU for me? If you have the wiring diagram, it's simple, just like maybe some 10-20 connections. Maybe 1 hour at the max, you are done with the wiring, you can start tuning, right? It's pretty simple. But if you go with remaps, right? So the whole point of this webinar was about tuning as well as remaps. So if you go with remaps, then things are not all that straightforward, right? So OEMs, they have quite a lot of other consideration. If you have a motorsport car, all you need that engine to do is run fast and run reliably for the duration of the race. But with OEMs, especially, say you go buy a car from an OEM, say you buy a, let me ask you this question, right? You want to go buy a car. Would you go buy, maybe if you had a 30 lakh rupee budget, would you go buy a Hyundai for 30 lakhs, or would you go buy a Toyota for 30 lakhs, or maybe would you go buy a German car for 30 lakhs? Now I'll put a question here. Okay. Now this car you buy, you will have to run it for the next 10 years. Which car would you probably end up buying? Would you buy a Toyota or a Hyundai, or maybe like a German car for 30 lakhs? And the catch being, you'll have to run this car for the next 10 years, maybe. What would you actually choose? If you are like most of the our fellow population, yes, you would definitely go with the Toyota, right? So the reason why you said that, why you'd go with that, is because OEMs also will have to look at their brand image, and brand image comes with quite a lot of things. So Toyota's brand image is, it is absolutely reliable. So the ECU actually does a lot of things to make the engine reliable for 4 lakh kilometers. Whereas a German car, you buy it, if you know you can change your car in the next 3 years or 4 years, you buy it, you have a whale of a time driving it, fun to drive, everything, you drive it, and then you dispose it off. Hyundai obviously sits somewhere in between. You have a lot of features. It's fun to drive, kind of reliable, but not exactly here, not exactly there. But I have not seen Hyundai engines being reliable after 1 lakh kilometers either. Right. So it's like every single company will have to optimize different parameters. So all, end of the day, what happens is it makes the ECUs very complex, right? The ECUs does quite a lot of these things. So ECUs become very complex. So you will not be able to completely start from scratch and build it up, because trust me, it takes more than a year and a half to get the calibration right for an OEM application. So 1.5 years of work, you cannot hope to redo it in about 15-20 minutes. So what we do is we just take the existing calibration tune, and we change only those portions where we know that it can kind of get us some power, right? So we just tune that area alone. We don't do anything else, which is why it's called as a remap. You don't map it fully, you just remap whatever is available, and you just do that. Now, if you remember, I said like with the standalone ECU, it's pretty straightforward to go and tune. So how exactly do you straightforward go and tune? Do you just like do it with just your computer, or do you need something else? More often than not, you would need these tools, right? Whether it's for petrol or it's for diesel, these are basically like some things which is, I would say, a must have in a tuner's kitty. So if you want to start a tuning garage or something for yourself, then it becomes essential that you have these tools with you. So the first one, the most indispensable one, is your wideband oxygen sensor. So unless you have a wideband O2, you will not know if your car is running rich or lean. So you definitely need to have a wideband O2. Second thing is a knock monitor. A knock monitor tells you when and where your engine is knocking. And the third important thing is to have, of course, a laptop and maybe some diagnostics. But the most important thing is to have a dyno facility to check. Now, why do you need a wideband O2? Why do you need a knock monitor? Why do you need a dyno to test it? Right? Here is where things gets interesting. Now, say you're tuning a petrol engine, right? Now there is a very small area between producing maximum power and knocking the engine and spoiling the engine. No, it's a very small area, especially with certain engines. Like say the Maruti G13 BB, it's a this big gap, right? You can kind of play around. You don't actually need a dyno. You can tune it without a dyno. It's a pretty big gap. But certain cars, okay, certain cars, especially like cars like the highly strung cars like the 4G63T, the Evos, Evo 4 until 8, 9, all these cars. Evo 10 is relatively okay, but 4 to 8, 9, these cars, the limit between getting maximum power and knocking and damaging it, it is very, very, very small. So half a degree this side, that side, you will start knocking. So when that happens, you cannot afford to okay, yeah, I'll get to it. Go Vartanan, right? So it is basically the spark advantages. I'll get to that, right? So it's just the limits to which you can tune the engine. So a little bit more you tune, the engine starts knocking, you blow it off, right? So in order to understand this properly, you need to have a dyno, you need to have a wideband O2, you need to have a knock monitor, and you need to securely sit in a place and work with it. Now, let me ask you, how much do you think this is going to cost you? Can someone roughly guess how much these tools or how much these things would probably cost you? Say you start with the standalone ECU alone. How much is the ECU going to cost you? A really good ECU would probably be somewhere about 35,000 rupees plus, right? And the really good ones, Motec, all of those things, they're definitely going to be like around 1 lakh rupees plus, right? Now, how much do you think the tuning tools are going to cost? So when I say tuning tools, I'm just meaning the standalone ECU tools alone, right? Um, at least 1.5 lakhs, right? So that pushes your investment in the whole thing to about 2 lakh rupees, right? And suppose you need to rent a dyno. The dyno is going to cost you approximately 2,500 to 3,000 rupees per hour, right? And then you need to have a car, and then you'll have to put it on the dyno, fuel, your engine wear and tear. So by my rough estimate, right? By my rough estimate, it'll cost you nothing less than something like $2,000. I mean, 2,000 rupees per hour for the dyno at the minimum, plus your fuel and other things, it's going to cost you somewhere about 10-15,000 rupees per hour to run your car on the dyno and learn. And another investment of close to, let's say, around 5 lakh rupees for you to get a car, put the ECU, put a properly tuned engine, and then go to the dyno and test and learn. So, which means if on average you need to spend 10 hours, 10 hours is less, but if you need to spend 10 hours to completely learn, your total investment in the whole thing is going to be about 5.5 to 6 lakh rupees, right? So now this becomes impossible for anyone to do on their own. So now, if you're wondering why is it like there are not many people who are probably doing dyno tuning, who are not doing this, why is it that most people are not teaching? I cannot teach you dyno tuning, or rather ECU tuning, without you paying me at least 10,000 rupees, and then another maybe 10 or 15,000 rupees for my time, right? So, would you be able to? I mean, would it be affordable for you to spend maybe say 25,000 rupees per hour, a 10-hour session, and you spend 2.5 lakh rupees for learning ECU tuning? I don't think there are many people who are going to be interested at that price point. Frankly, they would not be. I've spent it, right? I've spent it when I was learning. I spent it, but that doesn't mean that it becomes affordable, right? So I had to do it because at that point of a time, that's what I wanted to do. I probably had an opportunity to do it. I spent quite a lot of my time doing it, so I could do it. But how does a regular person? How does he do that? Right. Now this becomes the big question, rather the $1 million question. So if you're not willing to spend, or if it is not possible for you to spend so much, how can you learn dyno tuning? And most importantly, without actually working on it, how can you actually do dyno tuning? So for that, let me just share my screen. I'm going to share my entire screen. Hope it's okay with you guys. Let me know if you're able to see it. You are right. Okay. So now let me ask you, what does an engine dyno look like? Have you guys seen an engine dyno before? Right. So this is basically how the engine dyno is going to look. Right. Maybe let's take this nice looking thing. So AVL test cell. So this is how it's going to look. So your engine is on an engine dyno, and probably something like this. It's sitting inside a closed room. You are not standing next to the engine. Right. Engine is sitting separately, and you would be sitting in an air conditioned room somewhere separately, and you would be tuning from there. You would also be remotely controlling this engine, because it is not possible for a human to stand inside an engine dyno room and tune. Basically, because of the amount of heat it puts out, amount of noise it puts out, it is just not possible. And of course, safety, right? If something breaks, you're at risk. So also for safety reason, no one puts an operator, dyno operator, into the engine dyno room. Engine dyno is separate, the operator is separate. Now, what does the operator see? Let me probably like engine dyno, yeah, superflow. Okay, so what does the dyno operator see? Now the dyno that's here, that's sitting separately. Now all that the dyno operator sees is a readout like this, right? So you get a readout. There's a computer. You get a readout which says this is your horsepower, this is your RPM, this is your torque, maybe your temperature, and things like that, right? So this is basically what you see there. Yeah, maybe this is a nice one. RPM, horsepower, torque, AFR, which is basically a wideband. All those things, it just comes in over here, and you sit in an air conditioned room, happily sit and look at it. You also, in certain cases, get these graphs. Graphs kind of tells you like what exactly is the horsepower torque like. This is what you see when you start doing a dyno tuning, right? Sometimes what happens is you also have some really expensive piece of equipment like Horiba emissions analyzer, right? So they call it as a five gas analyzer. So if you are to go work in OEMs, Tata Motors or somewhere, you would find these equipments. They'll collect the exhaust gases, they'll pass it through what is called as a five gas analyzer, and it'll tell you what is the CO, HC, NOx, and all those counts. This is not the same as what you see in your emissions testing center, the PUC, pollution check center. It is not exactly the same. These are a little bit more advanced, and usually these equipment cost you about 1.5 crores plus. Now look at this kind of a setup, right? So this kind of a test cell with this engine, this is what you would see when you start going and working with, say, Cummins. Cummins has got 32 of these engine test cells. Tata Motors has them, Bosch has them. So pretty much every OEM, this is what they want you to look at. I mean, this is how you would want to work. Now, my question to you is this: do you think it is possible for you to like learn to work on these things while you are still in college? The simple answer is a big fat no, right? Why no? Because none of the places have got this capacity to spare. But still, every year some or the other one like moves out and they need new engine dyno operators. So you'll see posts coming up saying wanted freshers with engine dyno running experience or something like that. And they say you should know how to run load test on an engine. You should know how to measure emissions. If you're not able to even go intern at a place like this, they don't let you work. How is it that you basically qualify for OEM jobs? Or if you're not ready to spend 2.5 lakhs, 3 lakh rupees learning this, how do you learn how to tune it? Right. So this was basically the $1 million question that we had on our mind. So I mean, we have been working on it for the last 5 years, right? So I've been thinking of it for the last 5 years, and what we decided to do is simply this, right? So we built what we call as the engine dyno. We call it the virtual engine test cell, right? So now if you see this, right, this is available on our website. Just go to RainLab, and in courses you should find this. I'll share the link as well, or Raj can share the link to it. So now what happens is you see the dyno readout that you saw on there. So this is the dyno readout. So this basically tells you what is your torque, what is your horsepower is here. What is your COHC, NOx counts? All of those things are here, right? And you can also control the engine. Now, just assume that you're sitting in your room, your hotel, your house, or your hostel, wherever you are, and you're working on an engine which is just mounted somewhere else. So now let me run the engine at 6,000 RPM, 5,900, 6,000 RPM at 10% throttle. And what's my horsepower? I'm producing 3.27 horsepower. Why? Because throttle position is less. I increase the throttle position, it's gone to 19.31 bhp. But you see, emissions are also varying. I change this, emissions also do come down. Thermal efficiency varies, air mass varies. I'm able to kind of do all of these things just by running the engine virtually, right? So now you can assume that there's a real engine running, and this is how it will behave. You can also see there is a knock monitor here, and whenever the knock monitor ignites, then that means like I'm experiencing knock, right? So I've replaced your dyno, right? If you recall the list of tools we needed, I've replaced your dyno, I've replaced your air fuel ratio gauge, I've replaced your knock monitor, and I've replaced your car plus standalone ECU, right? So 5.5 lakhs, 6 lakhs is straight away like it is replaced with just this thing. Now, the whole point of the system is not just to measure what the engine is doing on the dyno, but actually to tune the engine. So that is what you see here. So you get to tune this. This is the ECU interface. So if you want it, you can go here, search for ECU tuning interface or software, whatever it is. Um, oh, okay, you have it here, right? So these are the tables that you would see in any ECU tuning interface, right? You will have tables like this. So I've just tried to keep it simple, table and a 3D graph. That's what I've done here. So I'm giving you a spark advance table. I'm giving you an air fuel ratio table. Air fuel ratios are here. And I'm also giving you a 3D graph, which basically represent how this looks. And you also have an option of actually like doing this calibration in an Excel sheet and then putting it up, because sometimes working with Excel sheet is always easier, right? So this is engine RPM versus throttle position. What is the spark advance value? A nice 3D graph for you to visualize things. So using this, you can learn how to tune, and as you tune, you can see how horsepower is going up or going down, torque is going up, going down. You can visualize all of these things. And not just that, you can also run what is called as a sweep test. So let me show what this is, right? I'm going to do a test one. I'm going to do it from 3000 rpm, 100% throttle. I'm going to run test 2, same 3000 rpm at 100% throttle. Now I can plot my horsepower and torque. Does this seem familiar? The same graph which your all your auto magazines publish, all the dynos. If you go search for dyno graphs, this is basically what you will get. Now, this dyno graph is a result of you doing your tuning there, which means every time you do the tuning, you start doing it properly, this gets better and better, which means you don't spend 10,000 rupees an hour. You hardly spend anything. You just sit at your room, you keep on tuning until you better the curves. Or if you're someone who's looking at going into the OEMs and working, then you can basically figure out what does the brake torque depend on, right? Does the brake torque depend on the FMEP, frictional mean effective power? Does it depend on brake thermal efficiency? Seems to be, because brake thermal efficiency and torque is kind of following a similar curves. But maybe if you took volumetric efficiency, then yes, there are, even more closely related, right? So there is quite a lot of these kind of things which you could do and you could learn from it, right? Which means, coming back to my original point, when you do the tuning course with us, this is exactly how you will learn. Now, tell me if this would actually replace an engine and a dyno. I would say 100% definitely yes. We have done this for the last 3 years. We have offered this to students at BITS Pilani, the MTech students. These are industry professionals, and they've appreciated working on it. Of course, as freshers, you would still need a hands-on, but that hands-on we'll offer it to you when you are able to come down. I mean, after the lockdown, you're always welcome to come down to our garage in Chennai, and we'll give you hands-on with all the tools. We'll have a couple of cars with us, usually most of the times, so you can come there, work on the cars. If you are lucky, if it happens to be the racing season, you could come with us to the track in Chennai as well. See how we tune at the track and things like that. So this is basically how we teach things, right? So this is basically how we add value to whatever you're learning with us. We kind of help you learn without actually spending this 5-6 lakh rupees, right? And once you have done the learning, you're okay with it, you think that yes, this is something which I like and I want to like pursue it, then you could maybe go purchase and you could do things. And of course, we do offer support for that as well. So let's move on, right? I hope that was clear with you. If you have any questions, do post it in the questions tab. We'll try to wrap this up with the next 10 minutes, and I'll take your questions after that. So now remember, when we started talking about these cases, I said ECU tuning is relatively simpler, whereas this is a little complicated. So how do we tune a complicated ECU? You need to basically hack into the OEM ECU and extract the tuning file, right? Which is why you need certain specialized remap tools and other things. But once you get the specialized tools, then basically everything else is the same. Once you have done that, of course, you have tools, various tools, yes, KTAC, CMD, PCM Flash. So we use quite a lot of these tools. You will get hands-on with these tools as well when you come down. But basically, this is something which you could basically like also learn by coming down, or we'll have separate video sessions for how to use these remap tools. So once you're done with it, then probably like you can also decide if you want to do it on your own, or things like that, right? So once you get the file out, then tuning becomes easier. You just go and straight away tune it and you're done with it. Now, what is the tuning process? So with a standalone ECU, you just connect, read the file, you tune it in the sense like alter it on your computer, you write it. Whereas with an OEM ECU, you gain access to the ECU first, which is hacking into it, and then extract the hex file. It is all in hexadecimals. It's a low level system, so it's all going to be in hexadecimal. You convert the hexadecimal into something which you are able to understand. Then you tune it, then follow the reverse process. The format you understand, you convert it into hexadecimal. You do something called as a checksum, which is a security algorithm, and then you write the hex file into the ECU. So the process of tuning, whether it's for standalones or diesels, it's kind of the same. It's absolutely the same, and only the read-write process is different, which we will cover anyways during the course of our of the course as well, right? So that's with the tuning process. Now, what can you expect to do after probably learning to do the tuning? There are two different ways in which you could go. So the first one is the aftermarket career track. Aftermarket is you get into business on your own, which is all motorsports. You're a mechanic, you want to start learning how to tune more advanced cars. All of those things, diagnostics, all those things goes into the aftermarket track. Whereas The career track 2 would be for OEMs. So you want to go work with OEMs, then this course basically forms the fundamentals to get into those things, right? So with just engine calibration, you cannot get into OEMs. You can, but the chances are very less. But this forms the fundamentals, because any automotive OEM will expect you to understand automotive electronics, automotive mechatronics, what exactly is an ECU, what is the control strategy, whatever the whole thing that they need for you to be a basic qualification that will come in this. Some extra skill sets, model based development, V&V, vehicle integration, all of those things we do have separate courses which will cater to it, right? So that's about the career paths which you guys can take. Now, I did promise that I will also teach you how you can learn tuning on your own. So now we are moving into the second part. So before we move into it, I think a quick 5 minutes. Let me just have a look at the questions, chat messages, and then I'll get back to you. Right. So Vaibhav, okay. Okay, sorry. I didn't understand that. Okay, so 1 rupee is, I mean, 75 rupees is $1 right now. So yes, I will explain that to you. I mean, once I finish it, because people might get confused when I start answering your questions. Read, write, and modify. I will get back. Shafiq, let me do that as well once this is complete. Right. Let me try to complete this, and I'll get back to you on that. So the first part was all about what ECU tuning was, how you could do it, and what careers you could have. Now I'll quickly take you through how do you learn ECU tuning, right? So now suppose if you want to learn tuning on your own, then how do you basically do it? So these are the steps which you would have to follow. So the first one is you will have to understand how does an engine work, right? You will have to understand the fuel and spark aspects of it, understand how the engine works. So now I'm not asking you to go back to your engineering books and learn about auto cycle, Carnot cycle. Nope. PV diagrams, nothing. Even to till date, PV diagrams is something which I don't understand. You don't need to learn it from that aspect. You need to learn it from what does fueling mean, what does spark mean, right? You just learn that thing alone, and things should be okay for you. Then once you're done with it, you figure out what is air fuel ratio. So what is rich, what is lean, what is stoichiometric? Rich, what does it do? Lean, what does it do? How does it affect performance? And if you're looking at jobs, how does it affect emissions? Do the similar thing for Spark Advance as well. And finally, find out how do you trade off between performance and emissions by varying your air fuel ratios and or Spark Advances, right? Because ultimately, as an engine tuner, every single day, what you do is compromising, right? What is compromising? You compromise between power and fuel efficiency. Maybe someone wants a street driven car, you'll have to do that compromise. Someone wants a motorsports car, you compromise between reliability and horsepower. You tell him, I'm going to sacrifice some reliability to give you more horsepower. Or to someone else, maybe going in for a rally or something, you say, I'm going to sacrifice a little horsepower to gain more reliability. It's all about compromises, and you'll need to know how to do this compromise in the best way possible. If I were to summarize what ECU tuning is all about, it's about finding the optimum compromise or trade-off between horsepower, emissions, reliability, these three parameters, right? So you learn how to do that. You have the virtual dyno. Virtual dyno is available for you, free to use for a period of 4 days, I guess, after which you can register for one more account and continue doing that. So once you have done this, once you have learned the basics, then what do? You get into the head of a driver, right? You basically become something like a psychologist, and you try to understand what the driver requirements are. Trust me, it is important, because every single driver drives in a different way, and he will expect the car to be tuned to suit him. So unless you get into his head and understand what this guy is wanting, you cannot tune the ECU as per him. So that's what we call as understanding driver requirements. You do that and understand how you could translate this driver requirements into ECU tuning parameters. Because the ECU tuning parameters, end of the day, you can only play with fuel, you can only play with spark. How do you play with these two things and satisfy different drivers? That's the name of the game. That's what we call as converting the requirements into ECU tuning parameters. Finally, if you are wanting to go into advanced ECU tuning or maybe remaps or something like that, you would have to understand what control strategies mean, right? So don't get confused by what you see on the picture there. Believe me, trust me, this is how they represent control strategies, right? So when you say control strategy, it is not like they'll say, draw a nice diagram and say, if temperature is less than blah blah blah, this is no, they don't do that. This is a scientific way. We call it as model based representation, and it looks funny, but for me this is a lot more easier to understand. But I understand for people who are looking at it first time, this might seem to be a little too much. So I would say there are a lot of guides out there are a lot of forums which tell you how the control strategies work. Break this down, figure out what alpha n is, what speed density, what blending algorithms are, figure out what is the air path, crank path, all of those things. You try to like understand it in your own way, and basically try to decipher how every single ECU controls the engine, right? So every single ECU will work in a different way. Say the Bosch will work in a different way. Continentals, they follow a different way. Siemens is going to be different. Your standalone ECUs are going to be different. So altogether, you might have to figure out some 10 or 20 different strategies, which I say is not too much, considering that there is almost 10 billion cars on the road. 20 different strategies is not something too difficult for you to learn. So you do that, figure out what are the control variables, how they are related, and once you've got that understanding, then it becomes easy for you to move into the next part of it, right? So then what you are able to do is open up any ECU, take up a controlled module like this, take up the tuning tables, and you start basically working on it, right? So like I said, what we teach, it is not specific to a particular ECU or a car. I don't say I'm going to teach you how to tune a Nissan SR20 DET using maybe an ECU Masters EMU Black Series. No, I don't do that. What I teach you is the fundamentals of how any engine, petrol or diesel, turbocharged or non-turbocharged, can be controlled. So then what happens is, you don't come back to me for multiple courses every time you want to do a new engine. You learn the fundamentals, you build up on the fundamentals, you become really good at it. You can apply these fundamentals for any particular vehicle, car, bike. It's entirely up to you. Any engine on any particular issue as well. So that's what our program focuses on. We don't focus on the application specific items. We focus more on um, the fundamentals basically, right? So now coming back to it again, like I said, once you have your virtual dyno to learn, what we manage to teach you is going to be, how do you basically interface to the ECU, what is the tuning process, how do you reverse engineer the hex files, what do you need to reverse engineer the hex files, and pretty much quite a lot about control strategies as well. And most importantly, what do you do if something goes wrong, right? Because that is not something which a lot of people do cover. So we do take a lot of pains to cover what to do in case something goes wrong. In fact, we also like do support you once you've completed the course, just to ensure that you don't go out into the field and you mess up some things, you blow up an engine. We don't want it to happen. It's bad for us, it's bad for you. So we basically try to make sure that you don't do up anything of that sort, right? Great. So how are we going to teach? This is about our program. I think I've already spoken about what we're going to teach, right? The virtual dyno and things like that. And what are the things that we teach? So apart from petrol engines, ECU tuning, right? What we also teach is, we cover quite a lot on diesel theory. So how is petrol different from diesel? How do you control diesel engines? We do that. Then we cover OEM control strategies. So whatever control strategies, the diagrams and things I showed, we cover all of those things. And most importantly, for those of you who are wanting to get into the aftermarket, we get quite a lot into performance modifications. So how do you design an intake? How do you design an exhaust? What is cams? How do you select a cam? Most of them think if you put a race cam, you gain more power. Is it true, or is it something else? We cover all of those things. And we also teach you how to turbocharge a naturally aspirated vehicle. So you have a car or a bike without a turbocharger. If it's a naturally aspirated, then we basically go and we also help you understand how you could build a turbocharger for this system and how you could install in it. And of course, goes without saying, we cover about ECU remap tools as well. So in case you want to start your own tuning business, we could probably help you with what kind of a remap tool to purchase, where to purchase it from, how to basically set up your business, what amount of an investment you need, and some things like that. So that basically brings me to the end of my presentation about ECU tuning and remaps. So now, before we go on to the questions, I just wanted to ask you. I just want you to answer this poll for us. So those of you who think this sounds good, if you're interested in joining our ECU tuning course, you could just vote on it. So this just makes it easy for our team to get in touch with you, ask for your specific requirements, and help you enroll. You would have already seen the course details on our website. So there are two different courses. There's the pro course, which basically teaches the entire thing what you have seen here. The list price is 17,000 rupees, but I think Raj can get you some kind of a discounts on that. And there is also the level one course, which teaches only the petrol part of it, which is I think 5,000 rupees. So for those of you who wanted it in dollars, I think off the top of my head, it's about not off the top. Let me say it's about 225 USD for the full course, and about $70 for the level one course alone. Right. So that's 225 and 75 USD. This basically brings us to the end of this thing. So before I get into the question, I just wanted to ask you just something about how effective this whole session was. So was this actually good for you? Did you actually understand how the tuning process works? If there is something you would want us to improve upon, then please do post your questions on the questions tab. I would be more than happy to make those changes in the forthcoming sessions. So now let me, yes, it looks like data flow diagrams. We call it as model-based design. Mayanko, like, yes, it is something similar to that. So let me start answering the questions. So if you have any questions, you could just put it up over here in the questions tab, and I'll take your questions. So do you become master tuners or slave tuners? I would say you will start off with being slave tuners. There's quite a lot of thing to it, because being a master tuner means a huge investment, right? The tools are expensive, and for every single car, you remember I said you'll have to decipher the hex files. So every time you decipher it, if you don't have the basic understanding of it, then you will have to like basically go and purchase these definitions. So purchasing these definitions is going to be expensive for you. So I would say start off with a slave tuner, and once you have gathered enough experience, you can pay the differential amount, and you can become a master tuner post that, right? Or you can buy a master tool and probably pick up tuning files from multiple people just to kind of save time or money, something like that. You could do that as well. What kind of a support do you provide after we certify? So see, I'm not exactly sure what support you need, but usually what we do here is we continue interacting with them until they have set up their tuning workshop. So that means right from figuring out what kind of a tools to purchase, if you're going to be a slave file supplier, which master to work with, what kind of an investment you need to do, what kind of a cards you need to concentrate, what's going to be your marketing strategy. This is basically all the support that we usually provide. And after we do that also, say we have one such student of ours who's working in Muscat, Oman, and he is basically like someone who's been from the electronics background. So for him, we still offer some diagnostic support on and off and things like that. So the support is there. You'll have to probably let us know what exactly you want. We are open for most of it, right? We are still a very small company. We like to build relations, so we are still open for pretty much anything that you might need, except maybe like traveling down to wherever you're from. Travel might not be possible at this point of a time. I would have loved to travel, but Corona and all those things, it's kind of thrown a spanner in the wheel. So except for that, pretty much anything can be done. Read, write, and modify the difference. Okay, Shafiq, I think you're asking about it from the standalone ECU point of view. So read is basically where the ECU pulls out the data from the ECU. Modify, if I'm wrong, if I'm correct, okay, so this is how it works. So modify is where you temporarily put the data into the ECU to check if it's working. If it is all to your needs, then you write it. So only when you write it, it will be permanently stored on the ECU. If you're just modifying it, then it is a temporary thing. If you cycle the ignition, if you switch it off and switch it on, then it basically does not work, right? So that, I believe that that's the difference you're asking. It's named different things in different ECUs, but basically this is what it does. Govardhan, how to create a VE table from scratch in the next session. Yes, I could try, right? So for which engine are you wanting to do this for? Maybe if you could let me know that, I can probably be of better help for you. It's not exactly simple, but I can definitely help. What type of programming knowledge do we need for remapping or programming a standalone ECU? What software is used? Akash, good thing. You don't need any programming knowledge, right? You need programming knowledge only if you go to a very highly advanced level of tinkering around with ECUs. But otherwise, you don't actually need programming knowledge. You just need a lot of hands-on skills. So softwares for standalone, the companies provide the support. So they give the softwares themselves. For remapping, if you are looking at developing the maps yourself, then you're looking at WinOLS, ECM Titanium, or Swift Tech, or something like that. So there are a couple of softwares which we use, but mostly we use WinOLS. It's pretty strong. It's pretty capable in that way. So we kind of use WinOLS for most of our use. Um, Mayanko, will we be able to provide services such as DPF, AdBlue, deletes within a short time? If you become a slave writer, then it is obviously easy. If you want to be a master file writer and then provide these things, then you would have to pick up a service like SwiftTech. So SwiftTech, the software, I think that allows you to kind of like write these DPF delete, AdBlue deletes, and all of those things. It allows you to do that. So yes, you will be, but you'll have to get the master tuning tools, and you'll have to get the proper tuning software as well, and you will be able to do that, right? How much damage does turbocharging an NA engine do in terms of reliability? For example, say Honda City 1.5. Okay, this is something which I'm qualified to answer. We turbocharged City 1.3 sometime in 2000. When did I come back? 2008, 9, sometime in 2009, I believe. And the car ran for about 75,000 kilometers with the turbocharger on it, completely stock internals. And then we removed the turbocharger, and then we drove the car for another, I think, until about last year, which was 2020. The car was a daily runner. So the car had done totally about 1.7 lakh kilometers, of which 80,000 was with the turbo. And with the turbo, we were running about 12 pounds of boost, taking it up to 8,000 RPMs, that kind of an abuse, and the car is still running, right? So I would say damage is pretty much, it's a relative term, depends on how well you tune it. So we had tuned it pretty conservatively. So I can also share some YouTube videos of the car when we first built it. I think that car used to do about 8.5 seconds 0 to 100, which was a huge thing in those times. So if I were to answer your question, you do it properly, you will not actually be doing any damage. Stay within the limits, no damage. Exceed limits, you start pushing the limits of engineering, then that's when you start breaking engines and things like that. What is a master tuner and a slave tuner? So there are two types of tools you can purchase. The remap tools are very expensive, so not everyone would be wanting to use a master tool, or basically want to kind of like buy all the software themselves and do it. People like me, basically, though I teach, I don't have time to sit with each car, spend some 20-30 hours, develop tunes. I don't have the time for that. So what I do is I have a slave tool. and my master file writer is a close friend of mine. So what we do is, if at all there's any car which comes up for tuning, I don't have to be there to tune it. I just get my workshop manager to read it and send it to me. They'll be able to basically, do the whatever the file tuned, whatever they need to do, they'll do it and send it back. So now with a slave tuner, you can only purchase tunes from the master you are admitted to. Whereas a master tuner can read the files and they can do the edits on their own. They can purchase files from multiple people. In terms of economics, a master, say a CMD, let's take CMD tool, or let's take a KES. So KES, the master version would cost you about 7 lakh rupees. The slave version would probably be about 2.5, 3 lakh rupees. So it depends on how many cars you want to do, how big a network you want to have. You would probably have a master and a slave. What kind of a software we're going to use for standalones? We go with Megatune, basically because it happens to be an open source software. But like I said, it is software agnostic. So you learn to tune with a virtual dyno or with any of the softwares you have. It's basically the same irrespective of whichever ECUs you go to. It's just that they look a little bit different this side, that side, but they are basically the same. So we will use our own virtual dyno that has got an inbuilt tuning interface. Or to give you a hands-on with the other things, we can probably go with Megatune or I don't know, if you want specific things, maybe auto tuner. We can go with whatever it is that you want, but it is actually agnostic, right? Will you be able to do live data analysis using diagnostic tools? What about sensors and actuators? So sensors and actuators, we do cover the entire theory about them, whatever you need to do. Live data analysis at this point of a time, we cannot do it unless we have a car. So maybe sometime down the line, I might actually be able to take one of my cars, connect a data logger, and probably do the data logs and probably show it as a recorded video or something. I can do that as well, but this is something which you'll have to do on your own to understand how it works. Comments on the rod to stroke ratio of the G16B and how it affects while turbocharging. See, rod to stroke ratio basically what it does is it puts, if you have a longer rods like the G16B, it puts a lot of thrust force, right? So thrust force is basically the force with which the piston is pushing against the walls. So that basically starts increasing the wear on the cylinder walls. So one side wears more thrust and relief, right? So longer the rod ratio, then more the component of force which acts on the thrust side. So if you are turbocharging a G16B, if you go for high pressures, then basically what happens is your engine starts wearing out faster on one side. It starts becoming oval, right? So that's because of the thrust side effect, which is why usually people don't prefer longer rod stroke ratio engines for turbocharging or high power application. Another downside to the G16B is that because it's got a longer stroke, the mean piston speed is also higher. So which means you cannot actually increase the RPMs and hope to make power at the top end. So that doesn't happen with the G16Bs. So it depends actually on with what kind of an application you're building it for. If you're looking it for a gymkhana or something where you need a lot of torque lower down in the RPM, then turbocharging the D16B makes perfect sense. If you're looking at a drag or a track spec car, basically where the speeds are higher, then a short stroke like the G13B, G13BB would make much more sense. What happens in live dyno tuning, in what we can write and alter parameters in ECU? I think you're asking about standalone ECUs. So basically in a live dyno tuning, what we do is we run the car, we see what is the horsepower it's producing, what's the torque it's producing. We check if the torque curve is smooth. If it is not smooth, we go make some changes in the ECU tuning files. Let the lockdown open up. Probably what I'll do is I'll probably be able to get some videos up for you guys as well, right? I don't I don't trust myself to go sit in a dyno tuning center right now, but if it does become a little bit more safer, I'll try to go maybe even host a session from a dyno tuning center or something for you guys. We'll see if we can do that. Mega Squirt and Tuner Studio, very good. One of the most advanced ECUs you can buy at this point of a time would be the Mega Squirt. Unfortunately, it is a little bit complicated to set up. Not all cars are supported, but if you have the budget for it, if you have the time, if you have the skills to set it up, please go with it. You cannot go wrong with the Mega Squirt. What engine do you prefer to do tuning and modification? Petrol or diesel, and why? See, personally speaking, I have one petrol and one diesel. They both have their advantages and disadvantages. Diesel, I have a lot of torque. It's good for me when I want to do a lot of long distance runs. I can still drive fast, and I don't have to worry about fuel efficiency. It's good that way. Petrol, just because I love hearing the engine note, I love revving the engines. I love toe and heels. So the petrol is a manual, diesel is an automatic DSG. So you ask me, I mean, I'm a petrol head, so I would say buy one of each, modify both of it. It's a very personal question, right? Very very personal question. Maybe if you ask me two different cars, maybe maybe you ask me a Hyundai i20 diesel, or maybe like a old Honda City 1.5 VTEC, I would say go with the VTEC, right? I mean, it depends on what car also. What's the minimum cost requirements for starting a tuning shop? Mohammed Aman. So I would say, again, relative. I would say around, without taking the real estate cost into account. Real estate cost varies between place to place. So without taking that into account, I would say just for tools, just for supplies, just for running capital for basic needs and all those things, I would say something like about 10 lakhs would be a good enough budget. So you would have remap tools, you would have some regular data loggers and all of those things. So I think 10 lakhs would be a nice thing for you to invest if you are not looking at real estate. Real estate keeps varying. So real estate, unfortunately, we cannot comment on that. Right. So I think we are through with the questions. So if there are any more questions, yes, there is. Let me tool. Is it possible to take a car on track for a session and tune it there a little bit, not from scratch? Yes, it would be possible. At least in Chennai and BIC, Budh International Circuit, you do have track days opening up. I'm not sure about how BIC works, but Chennai, you can come down, you can pay for a session, and both the driver and tuner, they need to have proper race seats, proper race seat belts, and you can take the car in and you can tune it on the track, right? But I would probably say, um, not strictly legal. I'm not supposed to say this, but take it with a pinch of salt. If you manage to come across a piece of road which is really deserted and there's no traffic, then doing the same thing on the track, doing it on that road would be the same thing, right? So we have actually like tuned the car, as in I sit on the driver's seat. I kind of like drive the car, give the feedback. Someone, a friend of mine or one of my guys, sit in the passenger seat and they do whatever changes I ask them to do. So we do it like that. So don't try to drive and do the tune yourself. Either you do the driving, get someone to do the tune, or you do the tuning, get someone to do the driving. Since I said like everything depends on the driver's behavior, it actually matters who drives the car. So you can do it on the roads as well, highways or something like that. After training, will you be able to do tuning up to stage 3? See, I mean, it is Mayanko, like it is. I wouldn't look at it in stages or anything like that. See, what I'm going to teach you is the fundamentals, the basics. So with the basics, I would say, please start with stage 1. Do some very limited modifications, get some experience, get a lot of experience, and then probably like move on to the more advanced ones. Because basically, if you're starting to do it as a business, the moment your first engine breaks, that is when you lose your reputation, and reputation is everything in this business. So I would say you're only restricted by your experience and expertise. So if you think you know what you're doing, if you can get support from someone, or if you're getting files from someone and writing it, there is no reason why you shouldn't attempt a stage 3. As long as you're able to keep track of things, it should be okay. But I would say more important is for you to protect the reputation of your business and yourself. So you decide which is safer and which is not safer, right? So that's a very personal question. It depends on your experience, and and what kind of a support you are able to get. If you're buying a file from someone, if you're doing bolt-on modifications, please go and do stage 3. Nothing will happen. It'll be totally reliable that ways. But if you're trying to do it yourself, then I would say please go step by step, or at least try to do it on your own cars, get some experience, and then move on to a customer's car. What kind of a feedback to look for while you drive a car while tuning? See, that again is a pretty huge thing. It's a huge thing to answer. I would say you will have to look at how smooth the car is on the throttle. Is the torque delivery proper? Sudden acceleration, deceleration, is the car okay? Is the fueling okay? Does it feel too jerky? Is the engine knocking? What kind of a feedback you get from the engine? Does the engine sound like it's struggling for breath or something? There's quite a lot of things you do. I think it's more intuitive. You can make it scientific. I can probably write down a list and give it to you, but it's also more intuitive. So you just drive it and you know it feels right. If it doesn't feel right, then you try to figure out what does not feel right. It's something more like that. Yeah, I think Shafiq, if you could, probably we have Shafiq here. Um, Shafiq, I'll unmute yourself. Where is Shafiq? Probably Shafiq has a lot of experience with motorsports, especially on the um, rallying side. He's from Malaysia and he's been a professional rally driver. So, Shafiq, your mic access is now on. If you want to answer the question. So, the question was, what do you look for? What feedback do you look for when driving? If you want to go ahead and answer it, uh, please feel free to take over and answer it.
Hello, yes. Are you here?
Yeah, we can hear you. Go ahead, Shafiq.
Yeah. Thank you so much for the session just now. I really enjoy and love it. The way how you explain is very clear, and because of
Shafiq, go ahead. So I'm just projecting the question here. So Viber was asking, what is the kind of feedback that you look for when driving a car? So if you could share something about when you were driving the cars, what kind of feedback do you look from the engine and things like that? It would be a very valuable addition to the whole thing here. Okay, I think we have having some issues with Shafiq's audio. That's okay, great. So probably like any more unanswered questions? Yes, there is one thing here. Is there any tuning tools which you do not recommend? No, there is nothing like I do not recommend. Each tuning tool would cater to a different category. So right now, if you look at it, we have the entire Alien Tech, we have CMD, we have PCM Flash, we have Bitbox, we also use B Flash, right? We don't use auto tuner it, but pretty much there is nothing like a good or a bad thing. I don't think maybe I might not go with Transdata, um, primarily because Transdata doesn't have any inbuilt advantages, except that some tuning companies use it. It doesn't have any other advantages with it. So basically, except for that, I don't think I have any tuning tool which I would not use. So hope that answered all of your questions. If everything's good with it, then one last you know thing from your side, please do rate our session. And if in case there is something which we can do to improve upon, please do let us know what we can do to kind of make things better for you guys the next time around, and we will definitely do that. Right. So if that's it, then thanks a lot for joining in, people. Mayanko, maybe like if you could drop us a message on WhatsApp, maybe we can discuss this more further, more in detail. Yeah, maybe it's time for me to share my number as well. So you have Raj's number already. This is my email address and my contact number. So if in case there's anything else that you need, you could basically get in touch with us. We would be happy to hear from you about that as well. Right. So that brings us to the end of the session. Thanks a lot, everyone, for joining in. Hope you had a nice time. Thanks for spending your Saturday morning with us. Thank you. Take care. Bye bye.